Hello everyone, and welcome to the Game Engine programming series where we write a game engine from scratch. Right now we are in the middle of implementing a DirectX 12 renderer, and so far we have created a D3D12 device, a command structure to submit work to GPU, and we spent the last episode writing a descriptor heap allocator, which helps us to easily place descriptors in descriptor heaps. Now we have got enough tools and infrastructure to prepare and set up the render surface, which is used to present the final rendered image on the screen. DirectX provides this functionality through an interface called a swap chain, which can be roughly described as an array of render target textures that will be swapped with each frame. So today we are going to write a class that creates and manages the swap chain. Here in the high-level renderer, we have a structure called a render surface, and it consists of two parts, a window and a surface. The window represents a window on this platform, but it's a platform-independent representation of that window. This is basically just an ID. And the platform-specific parts of it are implemented in this platform CPP file. The surface represents a graphic surface, and in the same way it's an API-independent representation of that graphic surface. And I'll take the same approach as I did for this window and implement the API-specific part in the low-level renderer, which in my case is the DirectX 12 implementation. The class for the surface is here, which is empty, and I can pretty much copy and paste everything from window. First, I'd like to let the compiler generate the default constructor here, because we already have a default initialization for this ID. We can copy and paste the type's ID here, and then copy this part from the window class. All functions here are pretty much the same as we had for Windows, except I added a new one to render this specific surface. As we did for this window class, in a separate header file we have the creation and removal functions for it declared. And the reason that I split those was that we don't need to have a reference to these functions to be able to use the window. But in case of a surface, we are always using the high-level renderer API anyways, so it makes sense to have it all in one place instead of splitting it. But feel free to split it if you feel like that's a better way of organizing it. I'm going to add a declaration for the surface creation and removal functions here. When we want to create a surface, we need a reference to the window for which we want to create that surface. Before implementing these functions, I'm going to expand this graphics interface with function pointers that we can use to call into the low-level renderer and call the low-level counterparts of these functions. For that, I'm going to add a structure here within this structure, specifically for the surface. We need to add a header file for accessing platform window class. Now I can go ahead and implement the functions that we have here and here. I think Visual Studio is a bit confused here about this render function, which we have a function pointer of here, but I think that's all we have to do to call into the low-level renderer. Then we'll cross the boundary from the high level to the low level part and add the API specific part here in the Direct3D12 renderer. First, add the common headers here. In D3D12, the object that represents a surface for rendering is a swap chain. A swap chain is an array of textures to which we render, and these textures are referred to as back buffers. After advancing to the next buffer for rendering, the previous buffer which we rendered to will be presented to the screen, and that way we swap the back buffers and front buffers, and that's why it's called a swap chain. The D3D12 surface is our low-level renderer's representation of a swap chain. In the constructor for this class, all we do is to add the window to which the surface is associated, and also check that that window has a valid handle. We also have a destructor that we'll call a release function. In the same way that we did for the resources, where we have the initialization of the descriptor heap split from its constructor, I'm going to split the creation of a swap chain from the constructor of the class as well. And for that, I'm going to add a function that's called createSwapChain. To create a swap chain, we need a factory from DXGI, and the creation function for the swap chain also expects a command queue, and we need to know what format we are going to render, because normally we render to 8-bit RGB formats, but nowadays we also have HDR monitors that are capable of displaying HDR formats, and therefore we are going to specify in what format we will have our final render. Like I mentioned before, we also have a present function. Okay, before we add a lot of functions here, I'd like to start implementing these functions to have a bit of an insight in what it takes to create a swap chain. The first thing that we need is a variable that holds a pointer to a swap chain interface. So let's add it here. To implement this function, I'm going to add a CPP file that goes with this header file. We call this function to create a swap chain, and the first thing I would like to do is to check whether this factory and queue contain valid pointers. And because we can call this function multiple times to create a swap chain for the same instance of this class, we need to first release everything. And as most of the things in DirectX, to create something, we need to fill in a description of that object first. And in the case of a swap chain, it is a DXGI swap chain description. I'm going to use description 1 instead of swap chain description, because then I can set the format explicitly for our swap chain. That will come in handy for later on when we would like to use other formats than the 8-bit RGB formats. A lot of members in this are really simple to understand, like width and height. And I'll explain some of these, but not all of them for the sake of time. So I encourage you to go to the documentation and look up what every member of this structure is used for. The buffer count is a number of back buffers that we'll be using, and I'm using the same number as our frame buffers, which is 3. It doesn't have to be the same number, but 3 seems to be like a magic number that fits everything. We are going to use our swap chain as a render target output. We won't be using it as a shader input or shared buffer or anything else. This one is just a render target output. This is a function that I'll write in a minute, and it will convert an sRGB format, if it is sRGB, to a non-sRGB format. And the reason is that when we are creating a swap chain, it will also create render target textures that will be used as the back buffer. And those textures can't be created using sRGB format. So we need to convert this format to non-sRGB first. And then when we create a view to those back buffers, which we'll also be doing when we implement this class further, we can create descriptors that view that back buffer as sRGB formats. And that way we can have sRGB output. So I wrote this function, which turns this specific sRGB format into a non-sRGB format. And if we give it any other format, it just returns the same format again. We'll use this surface as the final render target. And because we are basically just copying a finished image to this texture, we don't really need any anti-aliasing or super sampling, those kind of things. And that's why we set the sample description to 1 and its quality to 0. And I also tell it to stretch whenever I resize the window. We'll do proper resizing in another time when we have actual geometry to render and we can visually test if the resizing is correct. There are different swap effects, but DirectX 12 only supports 2 of those, which are flip sequential and flip discard. And since we don't use any of the back buffers as the input for the next back buffer, or we don't actually reuse any of those render targets, we just use flip discard so they can be discarded, and it's a bit more optimized way of using a swap chain. Now that we filled in this structure, we can try and create the swap chain instance. We are using this renderer for a Windows application, and on a native Windows application, we need to use this one. The swap chain for core window is, I think, used for universal Windows applications that nobody should ever bother using. This function expects a graphics queue handle for the window to which this swap chain is attached, the description of the swap chain, and we also have some optional parameters like full screen description and restriction stuff. And finally, a variable that holds a pointer to the swap chain. The swap chain has the ability to make the window go full screen when the user presses Alt-Enter. However, this behavior is not needed since we handle going full screen using a maximized borderless window. To disable this functionality, we can call makeWindowAssociation function with this constant as its parameter. On a side note, in addition to the documentation for DXGI swap chains, there is also a 3-part blog post with a lot of useful information and details on using swap chains. I'll put a link in the description below so you can just click on it and have a read. As you notice here, I'm using a swapchain1 interface because this function expects a swapchain1 as one of its parameters. But I would like to have a pointer to a more recent interface of swapchain, and that's why I'm going to use query interface to get the latest version of swapchain interface. So we have this member variable here that has a swapchain4, and we'll ask for a swapchain4. Then, if all of these function calls succeeded, we need to release this swap chain. And luckily, we have a function for that in core. And if we want to use this, we of course need to include the header for that. As I explained before, the swap chain is an array of textures, and we need to know which back buffer is the current back buffer. And we can get that information from swap chain by calling getCurrentBackBufferIndex. And then I'll put that information in a member variable. Now, because we are going to render to these back buffers, we need to have a render target descriptor for each one of those. And that's why we need to allocate slots on the render target heap that we have here in core. So if you remember, we have these descriptor heaps. If you haven't seen that video, just click in the link in the video and you can go and watch those. But we have these descriptor heaps here for render target views, depth stencil views, shader resource views, and unordered access views. And every time we want to render to a texture, we need to create a render target view of it and put it in this descriptor. Now, to use these descriptors from outside this translation unit, I need to add accessor functions to the header file here. And implement those in the CPP file. Now we can use the render target view descriptor heap to allocate slots for each one of the back buffers that we have in this swap chain. Of course, we need a place to put the descriptor handle that's returned by this allocate function. So I'm going to add a member variable that we can use for that. But that member variable holds more information than just the descriptor handle. It will hold information about the render target data, which consists of a resource and a render target view. And in order to be able to use this descriptor handle, we also need to include the resources header. And here, for each one of our frame buffers, we will have one instance of the render target data. Now I can put the handle to this allocated slot in the render target data RTV. And finally, I'll write a function that's called finalize that will finish up everything else that we need to do to create the swap chain. And I'm writing this in another function because it will be reused when we are going to resize the swap chain. The most important thing that we'll do in finalize is to create a render target view and put it in these RTV handles for each one of the back buffers. Here we get a reference to one of the entries in render target data when we are looping through each one of them, and then check that this resource pointer should be null because we are creating a swap chain and there shouldn't be any data already in there. And then we can use getBuffer to get a pointer to the back buffer with this index. And using this resource, we can create a render target view. Again, we need to fill in a description for the render target that we want to have. Now here is the part that we determine what our final render format will be, because here we have the non-sRGB format, but in general we want to view our final render in sRGB format, which is the gamma corrected format. For that, I'm going to add a function in the core namespace that we can call to get the default render target format. In the future, when we are going to implement things like HDR and other formats, we will expand on this, but for now, I'll just have something like core get default render target format. As you can see here, I'm using an sRGB format, and when we call this function here, it will create a render target view that will view the back buffer as an sRGB texture. And it is a two-dimensional texture that we are going to render to. This structure contains a union, and for the creation function to determine which one of these structures should be used, we need to set the dimension. So when we set it to texture 2D, it will use the 2D texture RTV. And finally, we can call create render target view. When this function creates a render target view, it will put it at this address in the descriptor heap. And that's why we allocated this slot. Next, we are going to get some size information about the swap chain that we just created. So the size of the back buffer textures that we just created should match the size of the window that is associated with this swap chain. So we're going to ask for that information and assert that the dimensions match. And then we also use that information to fill in the viewport and the scissor rectangle. So the viewport and the scissor rectangle are the areas to which we will be rendering. And here I'll add a viewport and a scissor rectangle to hold that information. Here I created some room for the description of the swap chain that we just created. And then we can fill in that description by calling getDesc function. And that way I can get the width and height of the swap chain back buffers. And then we check if those dimensions agree with the size of our window. And then I can proceed and put this information in the viewport and the scissor rectangle. We always use the entire surface to put the final render on, and therefore we set the viewport and scissor rectangle to the full width and height of the surface. This concludes creating a swap chain. So when we call this function, it creates a swap chain and allocates render target view handles for it. And in this finalize function, we go through each of the back buffers and create a render target view for each of them, and also get some information about the dimensions of the swap chain. There are a couple of functions left to implement: present function, resize, and release. From these three, I'm going to implement present and release. And as I mentioned before, resizing has to wait until we have something to actually render and we can visually check if resizing happens correctly. So let's implement present and release function now. Here I release the resource because we have a reference to that, and also I free the allocated descriptor handles, also known as render target views. And finally, when those are all released, we can release the swap chain itself. Releasing the swap chain would fail if we don't release the other resources first. In the present function, we check that the swap chain pointer is valid and then call present function from swap chain interface. And because it advances the backbuffer index, we need to get the next index by calling get current backbuffer index. But this function is a constant function, which means that it can't modify any of the member variables. I'd rather like to keep this function a const function, and therefore I'm going to add a mutable keyword to this member variable. That means that it can be modified or changed by constant functions. And we have the resize function, which I leave empty for now, and then the implementation of this surface is complete. Then I would like to also add some convenient functions to get the width and height of the swap chain along with some other functions. I'm also getting an error here, which is really not useful because it's kind of incorrect. But when I get something non-specific like this, which doesn't really make any sense, that's most of the time because I used some kind of class without including its header file. So I'm using descriptor heap here, but of course the resource header file where this descriptor heap is defined in is not included here. So I could either include the header file here or forward declare the descriptor heap class. And I'll do the latter because we are just having pointers here and it's better not to include headers in other headers. So here I'm just going to forward declare descriptor heap. Now there are no more errors and we are ready to plug this in the rest of the renderer. In the next video, I'll write the code for creating and removal of D3D12 surfaces in core CPP and use it to present the backbuffers in the test windows. Thank you so much for joining me today, and I'll see you next time. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus, there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!